is Raj Thacker, and what I want to try and present you is some simple system design concepts that will aid your planning better. I've used an example I've used in the past within aerospace. And so, just going to go to the next slide. It's a quick agenda, but the decks will be available. So even though I'll spin through them, you'll have all the data available for you. Just a quick introduction to myself. Yep, I come from an aerospace background, electronics, and I've been involved in standards. And I literally finished my PhD this year, and it was on the effect of chemical regulations in the aerospace and defense sector. From a work perspective, I developed systems in Rolls-Royce Aerospace. I wrote a global aerospace standard to do material decorations, but at the same time, it was like, I've done this to try and get supply chain data, but what's missing? How do you roll the data and information up internally within organizations? And that's kind of what the focus of my research was. And you can see that I work in multiple trade associations and sectors, and you can contact me on LinkedIn or wherever. So what I want to talk to you about is first, like, what's the problem that you're trying to identify, a risk or an issue that you want to programmatically solve with some basic system design concepts. And so what I'm trying to present is like, okay, a very simple concept that how do I identify chemical substances? Where are they and what risk do they pose to my organization? So this diagram here is what I always call the article transformation cycle, where you take materials and then you make products, sub-assemblies, and finish and try and distribute to consumers. But the problem is, it's like you have to identify what chemicals are used wherever, either through things that you make and define internally, or things that you source from the supply chain. So the issue is always there, but this is what I'm trying to resolve by trying to show you some simple steps. Okay, and so you could use the outputs of this presentation to then go back to your organization and justify, I don't know, having a regulatory compliance system or updating the system you've got to make it enhance it further. First step is always identify stakeholders. I'm just going to do this briefly. So I always do it in a simple diagram to say, a block table to say, define the stakeholder and give me a description of their role. And so when you look at internal stakeholders, you could make some basic assumptions, but this is very, very high level. It's not meant to be sort of complete end to end, but it gives you an idea to say, well, this team does this team does this. And from my perspective, even though I worked in a lot of those areas, I was actually in the compliance function trying to figure out what are the impacts. So this is very, very high level, but it gives you an idea that you map your stakeholders out first. Then you can look at external ones and see what roles and things they do. Yep, very simple. But once you've got your stakeholders identified, you can then apply what's known as SIPOC, or this has been around for ages. I mean, donkey's ages. My first degree is in economics. My second stuff's all engineering and computing. But the input-output model was first around in the 40s, and this guy didn't win a Nobel Prize, but many years later, he just took the concept of something's an input, something's an output, and then he did a matrix to say, well, what would the effect would be from an economic perspective. That model stayed around for ages, and then it wasn't until the 70s that you suddenly saw, with the advent of systems engineering, you suddenly saw an extension to this called the input process output model, which is like, okay, just extends by saying, okay, there's an input, what happens to it and what's the output? But you probably see this a lot in other areas like FMEAs, even though that was in the 40s, that kind of had cause and effect. It's the same type of logic, but what I'm going to present you is the simple tables rather than doing all the, because when you start looking into this, you can do the basic tables and do some crazy matrix, but they often send you in a multitude of different directions. So based on the issue in hand, the task that I want to solve, I'm going to present you what we use in PFMA, which is like the process failure error mode analysis, which I first got introduced to this at Rolls-Royce to look at things when a process would fail, or it didn't have to be a manufacturing one, it could be a system one anywhere. You would try and look at what went wrong and throw rocks at it, but we were always taught to use this SIPOC analysis to say, who was the supplier to that function, what inputs did they have, what were they doing, what were their outputs, and who were they feeding off? I found this to be really useful when I was trying to write global procedures, because often I was in one part of Rolls-Royce, like the civil aerospace division, working with the defense division, but there was a multitude of different sectors that worked with me, like nuclear, marine nuclear energy. They would, you thought the same processes applied globally across an organization because they were supposed to be global procedures, but then you found that different divisions and different sectors had subtleties in their approaches. So I went back before revalidating my procedure and saying, okay, let's do the SIPOC analysis against everyone to make sure it's a right fit in the context before I develop the detailed process. And so I'll quickly go through these, but you can see that from the original materials function, you could see a stakeholder to those guys are the actual companies that provide chemicals from the chemical sector. What do? They give you data like in material sheets and statements, and some of it, these requirements could be from customer requirements. But for the materials function, they're going to define the chemicals and substances and mixtures that will appear on material, which is like the finished product, and process, which could be used to in the process of manufacture. And some of their outputs, well, obviously the specs, but their data could be used to feed into safe use guidance and disposal instructions that other functions such as design, HSE, and manufacturing can use. So that's really the idea. You start by mapping out your stakeholders. Then from your stakeholder analysis, you can do the SIPOC analysis that then says, well, who feeds them? What are their inputs? What does that stakeholder actually then do and produce? And who does that stakeholder then feed? It's the same when, if you look at design now, they're obviously going to look at what's available to them to make products, but they have to use the material specifications in order to create the geometry drawings that are always based in aerospace and fit, form, and function that are then used by engineering. I'll whiz through these. So engineering obviously need the geometry drawings to then produce the machine and test and inspection procedures. Manufacturing would then say, well, we've actually got to produce it. So sometimes these terms are interminglable, but from my experience, engineering it's like design engineering, and manufacturing is the ones guys that are going to define the actual manufacturing steps and processes. Then you get to purchasing, which kind of does things like the make buy decisions. Do we, based on the data available from engineering, design, and manufacturing, they'll make a decision whether to make the product in-house and procure all the materials, or they will engage with a supplier to say your third-party supplier will outsource the manufacturing to you. Again, you can see these behaviours, and there's many more functions in a company that you could have like an accounting function that works with purchasing, or a quality one. But I've kept it really simple. But you also have sales, of course, who, whilst they require data from HSE and manufacturing, they're trying to get that demand and generate sales with a customer who ultimately will either go to customers of theirs are either going to manufacture. I should have put purchasing there, but and then you've got health and safety who will look at the data and say, is there any hazards associated working with the materials function? Look at any exposure scenarios. Look at any safe use handling instructions internally, and then enforce the procedures that it define. Then you come along to compliance, which was kind of where I lived for about several years, where you're trying to roll that information up against different chemical regulations and declarable substance lists and different actions that you have to do. So you have to look at all the data that you've got available internally and from externally defined data sources, roll it up into some sort of system, analyze it, potentially perform the supply chain outreach if purchasing don't do it, and then make, from all your analysis, then look at the data and say, what do I have to do from a regulatory sense in terms of notifications to a regulatory body, but also based on the regulations, make the legally obliged applicable obligations you've got to provide data to downstream users, regulators, and but that's basically it. But the role of compliance would again touch all functional areas of an organization. But the idea would be you take the stakeholder, you've identified it, you work with the stakeholder to say, in the context of this problem, where do you see your role? Who's giving you information? What is the type of information? How are they processing it? And then what do you produce that then goes on to a different customer? So it's really about understanding the stakeholder and their context within the given task or problem in hand. And bearing in mind, I did say the task in hand was all about identification of hazards produced with chemicals. This is just briefly looking at some information from the chemical sector you could use and say, well, in the chemical sector, there's often, they supply to themselves as either extractors or refiners, and they're giving you, they're creating these chemicals, but then they have to produce data. And when they produce data, they have to make these notifications based on their legal obligations. And this data should be made available to you when it's in the purest sort of chemical substance, mixture, or material. When it goes supply chain tiers above that, that's the information your sub-tier should be collecting and producing for you guys. But in aerospace, we always have these specialist processes and services where I could buy a piece of raw material, have it part machined or heat treated, or then passed to a supplier who will then apply some other finishes and coatings to it, who then comes back to me. But it's the same logic again. They're a stakeholder, they're doing things on your products potentially. What are the types of products? And you have to identify, okay, what did they actually do? What was a chemical? What was a hazard? To try and roll their information up, which, because it may appear on yours, because if the chemical appears in the finished product, there's a risk. Or if the chemical's used in, say, the EU and it becomes controlled by an authorization, you need to know that in order to make an authorization request for continued use. But obviously, again, it's like the customers are pretty much the same. So I won't go too much into this one, but it's like the actual manufacturing supply chain itself. Beyond, so this will be like articles and products and semi-components. They'll use the same logic of providing things, but they all have to sort of generate this compliance information that as outputs with safe use instructions and disposable instructions. If you don't ask for this information, you're never going to get it, but you have to understand that it's there. They've got obligations to provide it. When you're trying to define something that looks at all hazardous chemicals, you have to think about the end goal, which is the regulators, but also provisioning data to your end customers regarding the information. And this is why SIPOC, I always like it at this level. I don't like some of the matrices that come beyond it because they tend to get very confusing, but at a very simple granular level, if you map these things out like in this sort of manner, you could see there's a real good bucket of information in the context of a solution or issue that you've got that then helps you define it, refine it more accurately, rather than just making base assumptions. You need to look at the issue, identify the stakeholders. And this isn't rocket science, but if you do it, it does actually have some huge benefits. And so when I did it both in a practical sense for doing my system boundary diagrams and developing my system operating procedures, but I also then used it to make sure the things I developed, the procedures were robust. And I refined it again as part of my PhD research, working with a lot of different aerospace companies. But you can see a system context diagram, it can be just a boundary or an expression of things. But you can see from the SIPOC analysis, you can plug a lot of information in, and then that highlights in the context of the issue that you've got where things are going to be needed to be done. I do apologize because in the presentation I took out some of these functions just to keep it high level, but you will see it in the PowerPoint in this slide to show that this will be the aerospace company, and then what do they really need to do in terms of red, and then the green is where the money's coming from. The top level will be like examples of subsystems that are in the company, and at the bottom is functions that then need to feed in data. This is one example of a SIPOC diagram. And this is the more complicated one, sort of that tells you like, okay, this is more like a classical boundaries diagram that then looks at all the different sort of things that could happen in different areas that affect you as a company in the types of things you make. And then you look at it, you'd have to then look at it, involve it to say, well, oh, if I go back, you look at it in this context and say, well, where am I using chemicals, where they're flowing in from, to then a potential, this is my overall context where things could happen as a result of a chemical regulation or a chemical becoming more restricted, as well as identifying the hazard. You need to make sure that if you're manufacturing things, you need to touch and tell people, obviously you've got the regulators, but you need to make sure you've told the MRO side, which the maintenance, repair and overhaul, which could use your products to repair and renew, as well as all your end users, but as well as potentially the waste stream operators. That would only apply in Europe under the SCIP database, but it's a really high level diagram to say that's been pushed out from doing the stakeholder and the SIPOC analysis. You then get into, this is what the new sort of kids on the new kids are all doing. It's like, this is like a similar approach to the systems diagram, but this is more like a strategic level. It was like it's a crazy box diagram, but you look at the key activities and you then formulate detailed strategies. It's the whole point. And when you search for it, just search for business model canvas, because everyone's using this a lot in different organizations. This is like an overarching strategy that you can then develop functional strategies to then implement things more. But I'm not going to go through this at length, but this is like that SIPOC diagram applied in a business canvas model to then show, okay, what are the key activities, and then develop a strategy from it, which you can then use to escalate and highlight issues to senior management. We can see everything there sort of been plugged in and plucked from the initial analysis that you would do on SIPOC and the stakeholder analysis. You then derive things in value propositions and relationships, channels, and value streams. So this will be like an overarching strategy you can give to your senior management. And what usually happens in practice, in realities, is that those SIPOC tasks between one stakeholder and another, I've seen a lot broken down into a very simplified BMC diagram that just talks to the relationship between one functional area and another and key activities, which again, you can then, it's up to you. You can either use that, or you put that into your system operating procedure, or use it as part of the process to evolve to create your procedure to address an issue. It goes from, that would be like a simple function to function area based off SIPOC analysis. But there's lots of tools out there, but this is like a very, very low, I'd say low level implementation approach. Well, you can go into details, but when you start doing the matrix and things, you often find you're going away from the objective you're trying to resolve. I think that's it for me. I think I'll take questions now. Stop sharing.
Thank you so much, Raj. That was excellent. A really nice example of how we can use some very simple techniques to generate some powerful results. Do you have any thoughts about how people might go about introducing this type of process into their business if they've not done this before?
Well, yeah, I mean, the early stuff is really easy if you think about it. Identify your stakeholders and then engage the stakeholders with the SIPOC analysis to make sure you explain to them we're trying to resolve this issue in this context, and you tell me what you do in this context. And well, if a stakeholder, then you can develop it further and obviously have dedicated teams. It's about pushing that thing onto the company to say, we've got an issue that needs to be addressed. I need to set up a team of stakeholders, and you can't actually use it in the initial stakeholder discussions. Could be a great starting point to then develop the processes afterwards.
Thank you. Yeah, so a question's come in from Gareth. Are there any common mistakes when applying the SIPOC process that you could share with us?
The common mistake is that you've not actually talked to the stakeholders first and looked at identified their role, the things they use, their roles, and in the context of the issue you're trying to resolve. That's what happened to me at Rolls-Royce, to be honest. We were so far drilled into using the corporate global procedure that when I tried to do that for bringing in a compliance system for chemicals, and I engaged with different sectors, specifically energy, marine, and nuclear, you realize that they had completely different approaches to doing things. And so I had to step back, I put my PFMEA head on and just do the SIPOC analysis with them and go back and rework everything using identifying stakeholders, doing the SIPOC analysis, making sure the system boundary diagrams were fit for corporate and their specific functional areas. And then you gather their requirements and make sure they fit into the procedures you're trying to define.
Yeah, I think that's a really important message for any systems engineering. You've got to talk to your stakeholders. You shouldn't be making assumptions about what users and other stakeholders need. And yeah,
100% correct. I agree with you there, because
yeah.
I was lucky because I came from an engineering background going into IT, so I was ingrained in doing all the proper engineering end-to-end stuff, and the software guys were going, we don't. Ugh. But I was like, I still do that today. I have to do it in an engineering mindset, figure everything out at every angle, then do the software, because software can go at multitude of different angles, and
Mhm.
you really have to take it programmatically, not rush in and not do things that you think everyone else is doing because they seem great. But that's why I think stakeholder analysis with SIPOC and then developing it further is a much better approach, because you're actually working the issue with the functions that should be providing you information.
So a question from Philip. It says, are common predefined parameters linked together to form an interrelationship matrix?
Yeah, that's what you do once you've done the analysis. You can create the relationships and like in that system boundary diagram, but don't prejudge them. You just like think of the context of the problem, and then think of invite anyone, and then say what would you do? What's your function doing in this area, and then build on it from that. Don't I think if you do the predefined ones, you might find you're missing things and potential things that could actually improve the problem a lot better by talking to all functional areas.
Yeah, thanks. Yeah, I think that, there's some various techniques we can use around that, where we have prompts and keyword catalogs that we work through
Yeah,
systematically,
yeah,
but we don't necessarily have predefined specifications, because there's that danger that you end up making assumptions when you
yeah.
reuse
Don't
them.
never do that. Never, because you then find out you it's like the iceberg thing, isn't it? You you probably tackled the 20% at the top of
Mm, mm.
the ocean, and you've missed 80% that could have really helped you out and made it
Yeah.
one hell of a good thing.
Okay, a question from Anonymous. How can this be designed so that rework is not all consuming?
I think the idea is that it's the other way around. It's to try and prevent you from doing rework. It's really you do it end to end, get everyone's engagement, make sure there's a common understanding of the thing you're trying to tackle before you try
Mhm.
to tackle it, to try and prevent the issue that you've got rework. It's all
Yeah,
about doing it upfront first. Not,
so that's what people might have heard referred to as left shift, moving the problem solving further towards the start of the process
yeah,
than at the end. And I think another important approach for that all-consuming rework is rather to move away from simple diagrams to model-based systems engineering, where everything's maintained on a model rather than
yeah.
interrelated diagrams that you have to manually update.
That's what this will feed into. If you do it right at the start, then you can develop something properly. To me, it was like the system operating procedure. But you're right. You can create the model based on doing the process up front first
Yeah,
before you then try and resolve something.
yeah. So you start off simple and it layers up, and as the complexity grows, then you need to move to a modeling environment to
Correct. Yeah.
maintain that. Thank you very much, Raj. Really great presentation.